Welcome back to D-Machine, the channel where we explore the hidden beauty of industry, craftsmanship, and the machines that build our world. Have you ever wondered how those small steel balls found inside engines, bearings, and grinding mills are made? Behind each one lies a fascinating journey, from the roar of a blacksmith's forge to the hum of a fully automated factory line. Today, we'll witness how raw steel turns into the perfect sphere, a symbol of precision, strength, and the progress of modern engineering. Long before automation, every steel ball began its life in the hands of skilled workers. Inside a modest workshop, bundles of round steel bars are stacked neatly, each marked with a tag, the birth certificate of the material itself. These bars are made of medium carbon steel, tough enough to hold its shape, yet soft enough to be forged under heat. Workers measure, mark, and cut the bars into short cylindrical pieces. The process may seem simple, but precision is everything. A fraction of an inch too long or too short can ruin the balance later. Once cut, these small steel blanks are loaded into wire baskets, ready for the fire. Then comes the soul of the process, the induction furnace. Here, the steel is heated not by coal or flame, but by electricity pulsing through copper coils. The metal glows from silver to orange, then to a blinding yellow, nearly 12 degrees Celsius. At that moment, it's as soft as clay. Each red-hot billet is pulled out with long tongs and swiftly placed under a massive hammer or press. A skilled worker strikes with timing and rhythm, shaping one end first, then flipping it to round the other. Sparks burst with each impact, a dance of heat and metal, repeated thousands of times a day. Underneath the grime and sweat lies centuries of craft knowledge. When to strike, how much force, and how to feel the steel through vibration. This is metallurgy not by calculation, but by intuition. After forging, the steel is inspected by eye, checking the color, symmetry, and surface. Those that pass are sent forward for cooling and cleaning. But every craftsman knows, what makes good steel isn't just how you heat it, but how you let it rest. The red-hot balls are placed aside to cool slowly, hardening their surface while keeping a solid core. It's slow, manual, and physically demanding. Yet in every piece lies a human fingerprint, the mark of craftsmanship that built industries before computers ever existed. And while the old way was beautiful, it was also limited. So, in the next part of our story, we'll see how the same process, once driven by hand and hammer, evolved into a masterpiece of precision engineering. Today, machines have taken over the work once done by muscle and instinct, but the essence remains the same, shaping raw steel into a perfect sphere. Inside a large factory hall, rows of steel rods feed automatically into a conveyor. Hydraulic rollers push them forward, perfectly aligned. Sensors and cutting heads coordinate in harmony, slicing each rod into equal lengths with almost no deviation. No sparks, no shouting, just the quiet hum of efficiency. Nearby, a digital control panel glows softly. Power output, 518 kilowatts. Heating, 89%. Temperature and timing all managed by algorithms, not hands. The short billets slide straight into the induction heater. Within seconds, they turn red hot, ready to be forged. No open flame, no gas work. As the glowing piece exits the coil, it's guided into the automatic rolling machine. Two massive rollers, each with a groove, spin in opposite directions. Between them, the steel is squeezed and turned. The shape begins to transform from cylinder to round. Step by step, through several pairs of rollers, it becomes more spherical with each pass. In mere moments, the raw billet becomes a flaming orb of steel rolling down the line. Lubricant sprays hiss constantly, keeping the rollers cool and extending their life. Sensors measure the temperature and force. Adjustments happen in milliseconds. Every sphere that emerges is nearly identical, within fractions of a millimeter. Precision no human hand could ever achieve. The glowing balls then roll down a sloped chute entering the quenching stage, a water bath engineered for controlled cooling. When red meets water, steam erupts instantly, filling the air with white mist. It's the sound of transformation, from soft steel to hardened metal. Inside, the molecular structure changes, forming a martensitic shell, strong, dense, and durable. Once cooled, the balls move into a rotating drum dryer, where they tumble gently as warm air removes the last traces of moisture. From there, they're sent to the heat treatment furnace for tempering, a precise reheating process that balances hardness with toughness. The final step happens in the inspection room. Each batch is tested using the Rockwell hardness tester. A diamond tip presses against a steel ball, measuring resistance. Every reading is logged by hand, a bridge between old craftsmanship and new science. A technician carefully notes the values in the inspection sheet: diameter, temperature, hardness, and remarks. Only the best make it past this point. From raw bar to finished product, the transformation takes only minutes. Yet each sphere holds centuries of metallurgy, the knowledge of fire, pressure, and precision. Look closely at one of these balls, and you'll see more than just steel. You'll see the legacy of blacksmiths, the evolution of machines, and the quiet perfection of engineering. From the hands of craftsmen to the heart of automation, the story of the steel ball is the story of human progress itself. What was once forged by muscle and fire is now shaped by data and precision, yet both share the same goal: to create something perfect. At D-Machine, we honor both the old and the new, the spark of invention that connects generations of makers. If you enjoy seeing how the world builds its foundations, from sawmills to foundries, from wood to steel, make sure to like this video, subscribe, and turn on the bell so you won't miss what's next. Thank you for watching, and as always, this is D-Machine, where industry comes alive.